hello, hello, hello. Hi, yes, hello, everyone. We are live. Man, I feel like I should turn the music down, but that's fine. How's everybody doing? Welcome to the first live stream. Nice to see me streaming. Hello. Hi, Volley, I'm assuming is how you pronounce that. Hello. Yeah, it's been a little while since I've posted anything, which is why we're here doing this live to kind of kick me back into gear, right? Hopefully, this is the first of many streams to come. So, hello, excited to see you here. And we're gonna jump into looking at Blender 4.4. Sorry, I'm just like, doing a new thing, you know? A little bit of just nerves of just like excitement, right? But yeah, we're gonna jump into Blender 4.4. Let me know if my audio is alright. That's one of those things that I'm not as familiar with. I know video, I know graphics, audio is not my forte. I tried really hard to make sure everything sounded alright, but if anything's too loud, if anything's too quiet, let me know. Yee. That's awesome. I'm assuming you mean just being back. Hey, thanks. I appreciate it. I don't know how much lag chat. I don't know how much lag chat has, by the way. So, if I don't reply to things immediately, forgive me. But yeah, it's been a minute. I want to take a minute and just kind of chat, by the way, if that wasn't obvious. But yeah, it's been a little while since I've made a video. This summer was a little bit rough, not gonna lie. I just for personal reasons, not gonna get super into it, but just wasn't. It's not that I haven't been working on things. I have. But the mental health has been a little bit of a struggle. And just kind of knowing what it is I want to be doing. Some spoilers, we're gonna pivot a little bit with the channel, not that we're getting away from geometry nodes, not at all. More, I'm just gonna try and make more art. Like, I have this huge project in mind that I've been working on in my spare time for a couple of years, and perfect audio, thank you so much, I'm so glad. Cool, because I was so worried that the music was gonna be too loud, but yeah, so big project I want to work on, has a lot to do with just like life. I don't know how to describe without giving away a lot. But big project, I want to do some simulations to make. I want to, you know, talk about architecture and storytelling and world building. Actually, you know what, that's a good way to talk about the whole thing. Is I want to do some world building. Like, if you've heard of Artifexian, it's a channel where dude does a great job of building fantasy worlds and whatnot. So I want to take my geometry nodes expertise and kind of build a planet. If that makes sense. Like, use procedural modeling to build cities and roads, continents, maybe even like some nature sims and some environmental stuff. Use all of that technical knowledge, do some research on how the Earth works and all of the science that goes into how nature works, and build a planet. That's like my ultimate goal. It took me several months to really figure out that's what I wanted to do, and that's where I want to take this channel. So we're gonna learn geometry nodes. We're gonna learn Blender, because there's a lot I still need to learn. We're gonna teach some of that. That's what we're gonna be doing here today, getting familiar with the newest version of Blender. And then my ultimate goal is to take all that knowledge and we'll start building into this huge project I have. I've talked about this a few times on my Patreon. A little bit of a plug, which I should save for later, but just I've also been posting things on Patreon over the last 9 months. I've been talking a lot there, and then not making content here on YouTube to push that. And it's free, by the way. There are some things that are behind a paywall, but I've been keeping a blog on Patreon, which is free and available to the public. because a lot of it is talking about what I've been up to and how I do that in geometry nodes, and I want to keep that information free, open source, and available, all of the good stuff, because that's the ethos of Blender, right? And that's why I love Blender. They're open source, it's available to the public, they're doing just phenomenal things, supporting artists, supporting the public, and so far it's working out, and I'm so grateful that Blender just exists, if that makes sense. Because it enables what I do, it enables so many other artists. So, speaking of Blender, now that I've kind of just rambled for approximately 5 minutes, why don't we switch gears just a little bit? If I could remember where the button is, that would be great. I think it's yes. Okay. Content. Thank you so much. I'm so glad that you like my free content. I try to put as good of work as I can. I'm a perfectionist, so nothing I do is ever gonna be good enough. You know, at least for me. But I try really hard to get things done and get it done as best as I can. So thank you. Check the audio left channel. Left channel only. Shoot. Oh, you are absolutely right. Thank you for pointing that out. Let me see if I can fix this real quick before we jump in to the release notes. Just give me a hot second. I don't know if I can talk and diagnose at the same time, so 1 second. I'm just gonna vibe to some lo-fi for half a second while I figure out this audio. Like, I know it's a problem with my mic. The condenser mic I'm using tends to only go to the left channel, but I thought I had fixed that in the software here. Like, I can switch it to be stereo, but use the one channel to go to both, right? I'm just kind of thinking out loud. Why don't I see an option for that? Let's see if I can add a filter to fix that. No? Alright. Well, shoot. Trying to think if I have another microphone, because I'm pretty sure that is a hardware problem. And I don't want to give you guys a bad audio experience, because that is the majority of the content, right? Alright, we're gonna have to turn to the Google real quick. Let me see. See if I can diagnose this only, like, as fast as possible, you know? Streamlabs mic, left channel only. Okay, I should be able to down mix to mono, so says the AI. Not that I want to trust the AI, but also a fast answer is appreciated here, you know? There's no need to waste your precious time. If it doesn't work out, we can live with that. That's fair. Give me 1 more minute, see if I can get this fixed, because I think I found an answer. Also, don't know how long ago you said that, so thanks for bearing with me. I really appreciate it. See if I can down mix to mono, whatever that means. I've mildly know what that means, but like, hey. Now I guess we can switch back to this so that we can at least see this beautiful graphic I made the other day. Wow, would you look at that? We're not going to talk about it today, but if we get through all of the Blender release note stuff, we'll talk about the project that's kind of the not the inspiration, but like the precursor to it, right? It's the thing that I did that then this is the next phase of. Yeah, I don't know. I will definitely fix that before next week. I will fully diagnose the mic, get that corrected, but if it doesn't bother anyone too much, I would like to get going because I don't want to make you guys sit here and just watch me fumble around with audio stuff, right? But if it bothers you, like, please let me know. I don't want this to be unwatchable, right? And your enjoyment is paramount. So I will accommodate. I don't want to spend forever fixing it, but I do want to fix it if I can. But yeah, next time I'll definitely have it fixed. I do intend to make this a weekly thing. I want to promise that so that I actually do that. I actually maintain a proper schedule. I also don't want to make promises I can't keep. So we're going to say, hey, Mondays, 9 a.m. Pacific Standard Time, Pacific Daylight Time. We'll be streaming, working on projects, looking at new releases, talking about some technical stuff, and it's going to be fun. So, with further rambling out of the way, let's switch back to the release notes. Yay, right? Blender 4.4 is out, and it sounds like there's some good features. Not the biggest update for geometry nodes, which, by the way, welcome. If you're here and you're not familiar with the channel, we take a look at Blender. Obviously, you're here for that, right? But specifically, I like to focus on geometry nodes. So we're going to mostly take a look at geometry nodes, which haven't had the biggest update, but Blender 4.3 was huge. And if you guys want me to go into Blender 4.3, we can also talk about that, because I didn't make a video talking about the updates to 4.3. So we can do that after taking a look at this, if you guys would like to. Otherwise, I have a project we can talk about, depending on how much time there is. I'm not going to be streaming all day, but by noon my time, so like 3 hours, that's around when I plan to wrap this up. So we'll see how much time we have. Anyway, we have a couple of updates here, right? So, we've got an update to Subdivision Surface, and it looks like we have the Limit Surface option available. So, that's an option and a modifier, and I don't really use modifiers as much as I should. I should do so much more with modifiers than I currently do, but I have Blender 4.4 here so that we can take a look at these things, see what they actually look like, what's actually going on, do some testing, because in my experience, whenever they add stuff, whenever they make notes, not everything gets fully documented, at least to the level of detail that my stupid brain wants there to be, right? The Blender Foundation doing God's work, honestly. But sometimes the documentation can fall through the cracks. So we're gonna actually test things, see if I can figure out what's going on, and if not, then we blame Blender. No, I'm kidding. Then I will do more research and get back to you guys in a future video, right? So, okay. We've got, well, okay, we'll want geometry nodes. We're also going to take a look at, honestly, I added the geometry nodes modifier out of habit. No, we're not looking for modifiers. We're looking for the subdivision surface, because, yeah, it was subdivision. Okay. There are two nodes that do subdivisions. I don't know if that's true for modifiers. Again, I don't do modifiers a ton. So I had to double check that I'm looking at the right modifier. But okay, we've got, I think it's, yeah, it's in advanced. We have use limit surface. And just for reference, I kind of want to take a look. What does that mean in context of this modifier, right? Because again, I I use subdivision surface occasionally, kind of between geometry nodes if I need additional geometry, right? Because if you're not terribly familiar, these modifiers you can stack them effectively. I have a video talking about the realization I had of like having multiple geometry nodes. I should make this bigger so that it's easier to see. Maybe, I don't know. It's hard to tell because it's over here and I know my face is also over here. I was like, when I was setting this up, I was like, oh, I'm not gonna use this one corner of the screen. Watch me use this one corner of the screen now. Anyway, big realization I had a long while ago now. We can have stacked modifiers, and specifically stacked geometry nodes modifiers. So huge power move, have either your initial geometry or geometry nodes here at the top. Do a subdivision so you get additional geometry in a way that, like, yes, there is a node that does this in geometry nodes, but like sometimes you need a modifier to do it. And then you can have another geometry nodes if you want to continue on with your pipeline. That was a whole aside. Anyway, the point here is we now have this use limit surface toggle. So let me just read this actually. Place vertices of the surface that would be produced with infinite levels of, oh, okay. Infinite levels of subdivision. So it's like the idealized curve. If you, let's bring up some annotation actually. So subdivision, right? What it does is it takes your vertices here. Man, drawing with a mouse. I should have set up a drawing tablet. But this is your mesh, right? And let me just make sure I can see the chat. Hello! Igor? I'm sorry? I'm terrible with names and pronunciations, but hello! Welcome to the stream. So, okay, we've got subdivision. We have these 3 points, right? What Catmull-Clark specifically does is it finds additional points within, like, the idealized curve. So it finds... Let me erase some of this. Okay. So it finds, like, an idealized way that we can go through all of these points. Either through or around these, but it takes those points, idealizes it into a curve, and what this use limit surface toggle is letting you kind of define. Okay, should we do this piecewise function of finding this curve where we like take this subdivision at a point and that's where we're going to keep that point and move on, or do we find the idealized version, like the math function that defines this curve, and then add points along it? I hope that makes sense. I'm not sure that it makes sense. If you have questions, please feel free to ask, stop me, and we'll discuss it. Anyway, the reason we're looking at the modifier instead of playing around with the geometry node is because, and I need to figure out how to get rid of all of these annotations, but it's because we're going to jump into geometry nodes, make some new geometry nodes, get that menu out of my face, and we're going to add in the subdivision surface node. So, okay, yeah, we have limit surface. So if we toggle this on, yeah, okay. Oh, I'm curious now. Oh, we could measure this. Sorry, I should be saying my thoughts. So when we have this off, it looks like all of these points are evenly spaced, right? Which is generally what you want to see. Oh, I also have Catmull-Clark on. Shoot! Ah! Well, that I forgot I undid to get rid of the annotation because I don't know how to erase annotations. Oops. Uh, but in undoing a whole lot, it brought back the modifiers that I didn't want. So now we're going to bring back the geometry nodes we had there, and now actually look at this. And, okay, interesting. I didn't expect it to bring those points in. I'm not gonna lie. Huh. Okay, maybe I'm just absolutely full of crap and don't know what I'm talking about. And it's using a different algorithm to do the smoothing. Let's go back to the notes here. Interesting. I want to move on. I could talk forever about like the math, the algorithms that go behind all of this, but if we're just gonna cut down to the most applicable stuff without really getting into the weeds of how does this work, what does this mean for us, we have a new toggle and it changes where these points go, and that's gonna need some experimentation to at least for me, for what's the use case here. How can this be most effectively used? What is it actually processing, right? Because we're just looking at a circle right now. Well, we're looking at a plane that we're turning into a circle with the addition of yet more geometry. Okay. So, I figured it out by playing around further. So, I was right. I'm pretty sure I was right. We've got this curve that is forming between, essentially, is it this point, and this point, or is this point also subdivision? Well, okay, hold on. Let's bring up our spreadsheet. This is what I wanted to do, by the way. I wanted to actually test all of this stuff, show you guys how I'm getting to these conclusions, what's going on, how do we diagnose. So even though I'm not maybe explaining all of the thought process, I am trying to show how do we actually figure out what's going on, right? So, for instance, we go back down to level 0 here. Yeah, we've got 4 points. Just had to double check. Of course, I added in a plane, so it should have just defaulted to 4 points. We don't have a grid here, so it didn't default to 9 points with more subdivisions, because the grid, yeah, we have 3 by 3. We have 9 vertices. That's what I wanted to check here. We have 4 vertices at subdivision 0 with 1. We've added in another one, and this is the idealized curve because we have limited the surface. If we don't limit the surface, these 4 points on the edges, those are going to be kind of exactly in the halfway point, it looks like here. So like this point was initially here, and then it got brought in, but the midpoints stayed where they should be. And that's with this off. With this on, it pulled all of our points in, right? And that's what you would see if, like, this is closer to what you would see if you upped the number of subdivisions a whole lot, right? And we know this because if we turn off limit surface and we crank this up, it brought those in. And it would be the same thing with limit surface on, because as we toggle this, we don't see a change. But that change, we do see a change at lower subdivisions. So it's bringing low levels of subdivisions more in line with the idealized version of high level. I know that's what the notes said. So I could have just read the notes and moved on with life. But I wanted to test it. I wanted to understand what it's saying, what that means. How can we use this? So I'm not going to get into actual use cases, but knowing the technical what is this doing enables you to better use it. It enables you to find those use cases in what you're doing, to figure out you know, how is this actually working when you have a problem? Or I need to do X. Oh, this node does that. Right? Anyway, moving on. We are 25 minutes into stream, and we have covered, if I could switch to the right browser, line 1. So let's pick up the pace a wee bit, yeah? So the normal input node now offsets proper face corner normals instead of just face normals. So I'm pretty sure we didn't have face corner yeah, face corner normals for the normal node before. I remember reading this. Oh, I read this. I think based on the wording here and what I recall, we were just using face normals for face corners, and now we're actually calculating face corners. If you're not familiar with face corners, I envy you. Not because they're bad, but because I don't... Face corners are just terrible. I need to figure out how to clear this. How does one erase annotations? While I explain that, I will look up how to erase annotations. But face corners are kind of the geometry that defines your UVs, and you can have different normals depending on what different data type you're looking at. So it's more like a vertex, but you have 4 vertices for each vertex because it's related to which face the face corner is associated with. So given all of that, your normal calculations get weird depending on the data type. So it sounds like they're adding an additional calculation to the normal node so that we have that option for doing a different normal specifically to face corners. How that's useful is a little beyond me, because face corners are weird and difficult to work with, in my opinion. They're really important. I mean, they are essentially UVs, but working in geometry nodes, I have a hard time with that because face corners kind of bring in some weird logic. Like, well, first off, let me erase the annotations. I apparently can't talk and type and anything else at the same time, despite my best efforts. Sidebar view annotations panel. Okay. So we're in N view tool. No? Google, are you lying to me? And by Google, I mean Gemini, because I want to actually read a real article, but it is so tempting to just read the AI summary, especially when I'm trying to give answers real fast on the fly live. Yeah, display the sidebar. Annotations panel. Oh, that's in Blender 2.8. We're not in Blender 2.8. We're in Blender 4.4. This is why you always type in the version number whenever you're Googling, right? I should know this. I do this all the time. And then select the erase. What erase tool? There's not... I can't interact with this. Man, if I had thought about it, I should have made sure I knew how to use this, because I don't want to, like, Control Z that many times. That's just annoying and impractical. Sorry, thank you for your patience with me trying to figure out annotations. It's something that I should use more, uh, but I don't for whatever reason. Well, I know what reason. I don't present in this style very often. Shift space bar 5? Really? That's a heck of a shortcut. Okay, there's a little arrow there, and it makes me feel like there should be a drop down or something, but anyway, I'm just gonna move on because I don't want to waste time trying to figure this out, right? None of us deserve that. Instead, what we're going to do is take a look at normals, because that's what we were just talking about. Annotations. So, that's not the best geometry to test normals on. Instead, we're going to go to an icosphere. UV sphere might have been better, but we're going with icosphere because it's the superior sphere, and you can quote me on that. Okay, we're going to take a look at the normals. Yes, we'll just get a new geometry node set up. We're going to make all of the geometry node setups today. This menu is... We're going to have geometry nodes 0 to geometry nodes 105 by the end of the stream. But okay, so we have normal, and obviously the only output is the normal, so we have no way to control this here. What we're going to do is get the evaluate on domain node, switch this to vector, and... No, we're not going to plug that in there. What am I doing? We're going to get the viewer node, control shift left click if you've never used that hotkey before. And we're going to take a look at what this is doing. So the viewer is going to be set to auto. This is what domain we're looking at, right? And we're going to switch from point to face, so we can see, like, in point, for every pixel we're interpolating between the different point values. If we go to face, each pixel is determined by the face. So what's the normal for this face? Every pixel that it represents this face, we're all going to have the same normal. That's what that's saying, right? And so what is the difference? Let's get that menu out of there and just take a real close look, because I have no idea how subtle this is going to be. What is the difference between face and face corner? I saw nothing. I don't actively see a difference. That doesn't mean there isn't one. That means I can't see the calculation, if that makes sense. Like, there's probably a difference. It's probably just subtle enough not to be noticeable. I don't know C++, by the way. This is not going to be trying to read through the code. I just want to see if anything stands out to me, because this is like the next level below. Okay, we've got Blender just came out. Let's watch a YouTube video explaining how to, which, hey, super fair. Nothing wrong with that. Then, if you want like a further understanding of what the release notes mean, you go to blender.org, find the release notes, read through them like we're doing. Then, like, God level understanding of Blender and learning and figuring out how to, like, how all of this works, actually going in to the linked references to the source code? Yeah, to the source code? Figuring out what they've changed. Everything that is old and they're getting rid of here is in red, and what they've added is in green. And I don't know why I thought I could read through this real fast, but oh, okay. So legacy face corners. Huh. Interesting. Sorry, I'm just pausing at legacy because that means that they were, like... That implies that they've changed the algorithm for calculating face corner normals? entirely, and they weren't just importing like face normals. If that makes sense. I had assumed that we just, based on this wording, right, going back, that it now outputs proper face normals instead of just face normals. So I would expect it to say there face normals instead of legacy corner normals. So there's something maybe to look into that there. If that's something that interests you with faces and UVs, face normals, all of that stuff, like procedural UVs, this is something you'll probably want to take a closer look at. We're going to move on, though, because I can't really tell exactly what this means. But if you do procedural UVs on the regular, if you're using face corners regularly, then I would encourage you to look closer at that. It sounds optimized. It sounds like it's more accurate. That's great. It's not so accurate that I can tell at first glance what's going on, but I'm sure there's something really good going on here. For existing files, okay, this is maybe more important. The old behavior turned on automatically with a Boolean property in the sidebar. Oh, really? Okay, hold on. How would we... Okay. Normal, I don't think had this property before. Flat corner normals. So that would be with the legacy corner normal. Okay, so... I still don't see a difference, but again, if this is a big thing for the project you're working on, you now have a way to toggle on and off what you were using before, what's being used now. That's really good compatibility. I love that. But okay, so moving on. Let's take a look. We have collection and object input nodes. This is fantastic. I've been doing a lot more with collections and objects recently. Specifically, I've been working on recreating tiny glades in geometry nodes. That's been a very fun project. Again, check out the blog posts about that on my Patreon. I should include a link to the Patreon in this stream. I'll do that in a hot minute. I bring it up because it is a free blog. I'm not gonna continuously blast my Patreon. It's just genuinely I have been working on things. I do have some stuff out there available about this project that I'm referencing. And because in this project where we're recreating tiny glades, I've been instancing things, or I only have one piece of geometry that's being instanced to like a little house model that's fully procedurally generated with all of the gizmos to like adjust the geometry. There will be more assets that are instanced on those houses in the future, but most notably is that I have landscape that is not instanced but referenced, so that you can get some dynamic and reactive geometry when you're placing different pieces. Actually, I could just open it up and show you. Well, no. That's a whole tangent. I'm going to try not to go on tangents. My point is, I've been using this a lot. That is the whole point, full stop. So it'll be nice to see that we have the object... We don't just have object info, we have object... We have self-object and we just have object. That's very good. So we have that, and what I usually do to essentially do this is plug that in there, and now in the modifier panel we have an object. I mean, that's the self object, so it's not really doing anything. Also, I guess that's grayed out to let you know that it's not going to do anything with that. Is that new? I don't know that I've ever seen it do that. Right? Let me know in chat if you've ever seen it do this. But yeah, I've never run into that where it grays out an option that's in your input but isn't used for the output. That's really neat. I appreciate that. We might see that later on in the list of features, but in the release notes here. But anyway, getting back to it again, we have the object input node. So instead of doing this, or instead of like doing this and then having all of this extra stuff that we don't necessarily need every time, or like say we want to use this but we want to have multiple objects, we can have multiple object nodes that can all feed into here with, say, since I brought in 3, let's bring in the index switch node, because this should, yeah, we have an object option. All right, again, get that panel out of there. I don't want to see that. Not right now. So yeah, we can have all of these different inputs, all of these, like, as many objects as we want without cluttering up our inputs and without having all of this extra nonsense, which we may want, and we may even want multiple of these so that we're always referencing multiple objects and have all of the transform, location, geometry information at all times. But I really like having smarter nodes that take up less space and less processing, are more efficient, as opposed to just spamming up a whole bunch of nodes that essentially do the same thing, right? Big reason why I'm into for loops. Like, for loops and any kind of logic like that. We're talking about the simulation nodes, repeat nodes, for each element nodes. Anything that reduces the total number of nodes and total number of operations is fantastic in my opinion. Because we can just set it up once and then it'll do it recursively. Recursion is beautiful. Recursion is beautiful. Again, check out my Patreon where I talk about Mandelbrot and recursion. Anyway, so we've got the object node. We also have the collection. Well, we always had the collection info. Again, object info, collection info. But now we just have collection. I guess I'm getting a little tripped up by the fact that it is just object and just collection. There's no additional word after that. It feels like there should be something, but there isn't. And okay. Anyway, we have the collection node, and same exact thing. Plug this in instead of, you know, plugging that in, which is pretty darn good. I like that. I like that a lot. Are there any additional nodes to this? Doesn't look like it. They've added these 2 nodes, and oops. And I'm grateful for it. I love having new nodes like that. We're not going to see a ton of new nodes, but like, that's very good. Very, very good. So we've got the find in string node. Okay. We have the find in string node. I was just looking to see if this is talking about anything else, but no, that's other notes. We have another new node. And I guess we've got basically like a search node, right? Let's see. Find in string. So strings are actually something that I wish we had more functionality for, so I'm really glad that we're getting at least this much. So let's see, we have a string. Hello? No, I need something that I can search for something. Yay, Blender. We're just gonna... I can't think of anything. I don't want to do the classic YouTube like and subscribe. That just feels cheesy to me. But we have a string, and we can just search for E. Or how's about ER? And then we should be able to get a count. So we have... change this to attribute text, and we're looking at... I'm going to assume points. Yeah, we're looking at points. These are little bitty ones. YouTube compression is going to absolutely crush that down, but every point says 1 because in this string, we have 1 ER. Now if we switch that to 2, or sorry, switch that just to E, we now have 2. It tells us the total count. Also, first found, well, that's not going to work. Let's instead bring in the string to curves node. This is perhaps the better way to demo this node. We're gonna bring this. We're gonna need a little bit more logic, actually. What I was gonna do is take this, and we're gonna search for some substring, right? E or ER. And I was thinking we could take this substring and then plug it in and get some more information. Something along those lines? I don't think that's gonna work as quickly or easily. Like, there are things we can do trying to figure out what's the more efficient thing to do on stream, right? Now, instead, what we're gonna do is take the string to curves node, take a look at that, and wow, would you look at that? The string has become a curve. Now, we can do, let's just bring up all of the string nodes. We can, yeah, let's bring up slice string. That's a bit of a tongue twister at the moment for me. We're gonna bring that up, and again, string. What was the name of the node we were just looking at? Find in string? Yeah, so first found, I have a feeling, is gonna be, it's gonna return the position. And so we'll do that, and let's actually, okay. In order to actually slice this string, let's give it the string we want to slice, and then we're going to use another string node to create the string that we're going to search for, so that it gives us, well, the count isn't going to give the length. We need string length. So how many characters are there in here? And now we should be able to do the thing I was just talking about. And we're going to join geometry. Maybe should use a switch node, but whatever. We're going to bring these two together and take a look. And it looks like that has worked. So we've done first found. It's returned us an integer that says how far into this string is this string, so that then we can slice the string. We'll cut where we found the string, the string we're searching for, right? We're gonna cut it there, and then we're also looking for how long is the string that we're looking for. And we're going to set the length. So yeah, we've effectively cut out that substring. And so you can see that here. Let's add in a transform geometry node so that it becomes more obvious. Looking at the two of these side by side, we've achieved the goal, right? And I don't know how I would have done that before the find in string, because we can now do this with whatever strings we want to, right? I'm having a hard time thinking up words words to split it apart into substrings, but like, and trying to think of things that potentially have multiple occurrences. Because, yeah, we have first found, but another part of this is that you could have multiple different substrings in a sentence, right? Yeah, that would take more logic, and again, we should move on. We have many other things to discuss, but yeah, find in string, that's really neat. That'll be very nice for any motion graphics, any like live graphics. Like, I think about news broadcasts, right? If you want to be able to adjust all of that on the fly, obviously you're not going to do that in Blender, because Blender doesn't really have much of a live component to it, right? Blender kind of renders things out, and then you use that. It's not really anything that you use for live graphics. So maybe that's a bad example, but I don't know. There are reasons to use this. It's more procedural. It gives you more things to do with strings. It makes things easier to work with if that's what you're working with. So I like that. That's fantastic. The Join Geometry and Realize Instances nodes now preserve vertex group status of input attributes. Fantastic. Okay, what does that actually mean? So I don't know if I can give a more practical example or demonstration of this, but we've got a bunch of attributes on whatever geometry coming in here, right? And it used to be that not all of those custom attributes would go in and get merged if they conflicted, and now it sounds like it'll preserve that, if I'm reading that right. Let's just make sure. Now preserve vertex group. Oh, no. I said attributes. Instead of input attributes. No, I think I'm right. Yeah. Vertex groups are also a thing. You can establish vertex groups, which is why I hesitated there for a second. Yeah. We're not actually going to be playing with vertex groups, it sounds like. It'll establish a vertex group that was this geometry and a vertex group that was that geometry, and then when it puts them together, now we will preserve any attributes that were on one set of geometry and not the other, which is great because I have run into issues with that and had to use the capture attribute node to preserve those attributes going forward. Because, yeah, you join everything together. A lot of times, if you don't have a way to preserve those attributes, or if you don't have it on all of your geometry, it just gets lost. So that's very nice. That's a fantastic thing. We're not going to take a look at the geometry to instances node, because it sounds like it does the same thing. Or the realize instances nodes. That's actually interesting that it's the realize instances node. Because I guess, yeah, you can create different attributes on different instances, especially if those attributes come in before you instance geometry. That's how I've been getting a lot of different attributes on instances. It's by starting off with just different attributes at the start, right? So, okay, we've got all of that. The text overlay in the 3D view works for matrix attributes now. Oh! Okay, hold on. So, let's take a look at this at a cube, right? And let's just take a look at the position. So, if I'm reading this right, that's what they're talking about, is that we've got, or no, it wasn't vectors. They were talking about matrices. So let's, what's an attribute that already exists that's a matrix? I mean, your transforms would be that, right? Let's just take a look at our geometry. So we have position. You know what, let's just store a matrix, because I don't know that there is a default attribute. There's a word for it, but an attribute that already exists on your geometry. I don't know that there's a word for, or that there is an attribute that's already a matrix. So we're just going to create one in order to show this off. So quaternion would be one that we could use, because that'll just rotate our geometry if we were to actually use it for anything. And We could do that. And that way we get an example of how this actually works. So let's get a rotation. We'll just set it to whatever. We'll input that here. Call it rot. Because of course. And then we'll get a named attribute. Set that to rot. Put that into the... Right. That doesn't work. Because rotations are weird. Quaternions are weird and difficult, and this wants a single value, but this is technically a field. Even though it's a single value we've created for every element, this still reads this as a field and it needs to be a single value. Shoot! Alright. Well, okay. Actually using it wasn't the point. What we want is to see whether or not... There's no color overlay, okay. But there is text. Rotation values can only be displayed with the text overlays in 3D view. I'm pretty sure that's what this is talking about, right? The text overlay in 3D view works for matrix attributes now, which is great. Rotations are a matrix. They're a quaternion. Maybe we need a combined matrix, and we'll, instead of setting this to quaternion, because maybe Blender's calculating that in a different way than I imagine it is. We'll do that, and then we'll take a look at that. No color overlay. Aha! Okay, this is what I wanted to see. I don't know why I went to rotations first. Shouldn't have, but I did. We can now... I hope that's visible on stream. Let me know if it isn't. I don't really have a good way to make this text larger, like quickly. But we have this big blob of white if YouTube compression isn't working well. We have location, rotation, and scale, and it's broken it up into rows. It's got all of the labels of what those 3 rows are. It's a good way of showing all of that information on each element, and I'm glad that we have all of that text available. Man, before they added text to the viewer node, oh, it was so hard. It was so hard to diagnose so many things because I'd have to jump through so many hoops to get all of that information available in the spreadsheet and then know which point has what index so that I can look at. It was so hard. Or put it into a format that had a color component so that I could see at least an idea of what values were on what elements. Just having text is so huge, and I'm glad that they've added support for more domain types. That's fantastic. But okay, moving on. We've got some performance improvements. That's great. Triangles. We're no longer in BMesh. We're now working with mesh. Sounds good. That is more technical than I have any awareness of. But 30 to 100 times performance improvements, that's huge. That's huge, and I'm happy for it. And then the sort elements node is 50% faster. Also fantastic. I can't really test these things directly. There are tests you can do, but we'd spend a lot more time actually achieving that, and I want to move on. I'm going to take their word for it. Things are faster. That's fantastic. And then we have the node editor. The warning node now has dynamic labels. That's great. So it'll change how it looks from warning to error to info. I remember it not doing that and kind of just thinking to myself, I feel like that should change its label. So warning, to see this actually in practice here, we've got it reading error, now it reads warning, now it reads info. That's fantastic. I love this node. It's really good for diagnosing larger node networks. I need to use it more. But also, I don't know. It's one of those things I need to keep in mind, right? Because it's very useful for debugging and for labeling stuff and for producing tools, uh, making things for the public so that people can figure out, okay, I'm getting this error, and then ideally, as a tool maker, you have that documentation for what those different errors mean. Because this node, if you're not aware, also gives you text. Like that's what this message is. You can have a string that tells you, hey, uh, this expects the value between 0 and 1, and you're off at negative infinity. What are you doing? Nothing quite that smart, unfortunately. There's only so much you could write in here, but it's that kind of thing. It's a very good node. So glad that they just have. It just looks better. It reads better. It's more readable. That's fantastic. And then, okay, my personal favorite in this whole thing, we have snapping supported when resizing nodes horizontally. I guess they didn't include vertically, but taking a look again, what does that mean? And I haven't turned on snapping very deliberately because I usually work exclusively with snapping turned on, this magnet icon up here in the top right of your geometry nodes, because then it snaps to the grid and you can get nice straight lines. Like all of these will line up and it looks good. I like having the curved lines, but then using snapping you can get straighter lines, and there's something about the combination of like organic curves and then nice straight lines when it's all in a grid. It looks good. It looks good in my opinion. But for the longest time when you did this, it would adjust the size more like this, even though snapping is on. Like, this is what we've got, and that's fine, but if, say, this node starts off at this sides and we want these two to be more in line, like, I can eyeball that and get them close enough, but, like, this is so much better. Oh, that's nice. You know that they're in line. You know that, like, they're all a standardized size, right? I don't know. This is the kind of thing that just... It's the little things in life, right? It makes me so happy. But yeah, those are all of the changes coming to, this is already out, that are available in Blender 4.4 in geometry nodes. Because again, we're just looking at geometry nodes, but if you guys want me to go into other aspects of the Blender update, I'd be more than happy to take a look at them. I'm just not an expert in most of these things. Like, I want to know Python. I want to know grease pencil. I am not a grease pencil artist, and those people amaze me. I see that kind of art pops up into my feed all the time on YouTube. I'm just so blown away by what people can do with 2D and 3D. It's a kind of art style that I love and I can really appreciate. But at the same time, I'm like, I don't have the time to learn a whole new skill as much as I want to do that. And especially with Blender 4.3 introducing so much more compatibility between introducing compatibility between grease pencil and geometry nodes. Like, we can convert grease pencil into curves now. So we might as well take a look at grease pencil, because in the future I want to work with grease pencil and work with curves to make procedural things with grease pencil. That just sounds like so much fun to me. So yeah, let's just take a look at it real quick. I don't really know what I'm looking at, gonna be honest here. But okay, so we've got stroke placements, added stroke placements back. Great. I don't know what that means. Reduce size line. Of line primitive gizmo. Okay. Gizmo caught my eye for a moment because we have those in geometry nodes and that's all I can think about. Added auto masking, neat operators. I don't know why I'm reading through this, unless you all would like me to go through and really figure out what's going on. I'm more than happy to do that. Otherwise, we're just going to do a cursory glance, see what we can glean, right? So this does look like it's talking about geometry nodes at least a little bit, because we've added conversion from or maybe that's not geometry nodes. We're just saying, okay, hey, we've got a curve object in the viewport. So turn that off. I'm also going to turn off attribute text because we don't need that. We're going to create a curve, and it's just going to sit there in space, whatever. How do we convert that into a grease pencil? Because that's what it's saying we can do now, right? Conversion from curve to grease pencil. Oh, I guess they tried to introduce that in 4.2, but that didn't. Or maybe they got rid of it in 4.3? Can we take a look? Take a little look and see what the changelog says here. Oh yeah, when I was talking about this earlier, I mentioned different levels of like really figuring out geometry, or sorry, not just geometry nodes, but really figuring out Blender, watching the videos, breaking it down, reading through the release notes, and then diving into the source code. I should have mentioned, I usually don't just read the source code outright. There's almost always some comment up here at the top when you dive into these links that take you to the source code, and it's the comments that you want to read first. I don't know why I didn't do that earlier, but so this patch, let's make this bigger again. So this patch implements font to curves, okay? Legacy curves to grease pencil, and font to grease pencil. Okay, note that font to grease pencil is done by converting font to curves, then converting curves to grease pencil. I love that. I love a good, like, if it ain't broke, don't fix it. We don't need a conversion from font to grease pencil directly. If we already have these two pieces, let's just put them together. It's Legos. It's Legos, but code. Currently, we do not have direct conversion API. Yeah, no, that's fair. All right, neat. You can convert. I didn't even know. Well, I did know fonts or a thing. That's again in the category of things that I feel like I don't have a great grasp on, mostly because I don't use it often, and I don't see many people talking about this, at least on YouTube. That's got to be one of those things that are used like in niche corners and like more in production than just kind of making art on YouTube or making like small pieces of a project. That sounds like something that's far more technical and far more like the people who know and aren't going out to find tutorials, so nobody's making tutorials because nobody's gone, why aren't there tutorials? Let me learn this and I will make a tutorial. Does that make sense? I hope so. But it's neat that we have that support now. That's fantastic. I love that. We have modifiers. Previously, invisible layers were part of evaluated data. Okay. But this wasn't an intentional decision. Now invisible layers are removed from evaluated data. This means, for example, that they are no longer listed in the context of geometry nodes. Technically, this is a breaking change. In the unlikely case that hidden layers were expected to be evaluated within modifiers, their visibility needs to be toggled. Interesting. Okay, so what all does that mean? We've got evaluated data and unevaluated data. If I'm remembering this correctly, it's something that I actually run into in geometry nodes. So like you have evaluated data and unevaluated data, and if I could speak a little slower, we have evaluated data and unevaluated data. Evaluated data is processed on the fly, if I'm remembering this correctly. So like in geometry nodes, we're able to move gizmos around and we're able to adjust parameters to then get different geometry on the fly, right? And that's all evaluated data. Unevaluated data doesn't get applied in real time. So, like, a good example of this is our, yeah. Let me just build an example. Okay, so we're gonna get rid of that. We're gonna add a cube, and we're going to add in some geometry nodes. So this we're going to just real quick go home. We're going to use the set position, okay? And we're going to just give it an offset. We're going to set that here so that we have very clearly the parameters that we're adjusting. This is evaluated. Again, if I've remembered those definitions correctly, and if I haven't, just flip them unevaluated and evaluated, right? That should make sense. So we have a parameter that sets the position, and that gets evaluated here and modifies geometry, right? Now, if we add another geometry nodes modifier, but say in this first one, we're going to store named attribute. So we're going to take this offset, store this as a vector, and call it pose. Now we're going to store this after the set position, and in our next set of geometry nodes, we're going to assume we have the pose attribute, and we're going to set position again, and essentially just do the same. Oh, that actually worked. What the heck? Maybe they made geometry nodes better? Maybe they made this better? I remember that not actually working for some reason. Like, what I wanted to show was that it wouldn't do that until you actually applied the previous modifier, but perhaps I have that wrong. My bad. There's definitely something that, like, you have to apply it before it'll actually do it. Maybe it was subdivisions? No, that wouldn't be it. Apologies. I could have sworn I had that correct, but c'est la vie, right? There's something that you have to apply. I've run into it before. You have to apply the geometry nodes, or maybe a different modifier before it'll actually use that information. Oh, I know what it was. Oh, okay. Sorry. I know what I was trying to think of. Store named attribute is the thing that allows that information to go through. But if you didn't know that, what you would likely do is not have a store named attribute. You would take your offset parameter, plug it into here. And then, like, you have this output. So you'd be able to go, okay, cool, I have this, so let's copy data path and then plug that into here. Well, there's nowhere to plug it in. So that's what I mean is evaluated stuff are the stored attributes. That's the stuff that you're working with, and you save it onto the geometry. And that's all evaluated, right? The unevaluated stuff are the extra bits of information that get plugged into the output node. So offset here in this context, this is unevaluated. Nothing will happen with that offset until you apply this, until you apply those geometry nodes, and then that offset exists and can be used in other parts of Blender. But it's just not a good way of doing it. So that was a long tangent to try and explain evaluated versus unevaluated information. And I forget how that ties into here. Yeah, it ties in because invisible layers in Grease Pencil, they were part of evaluated data. So, okay, you wouldn't need to apply the modifier, and that's what we're talking about here is modifiers. You would not have to apply the modifier to have persistent invisible layers, but that wasn't intended, so that's what it was doing. Now invisible layers are removed from evaluated data, so okay, that's not persistent information. This means, for example, that they are no longer listed in the context of geometry nodes. Right, that makes That should make sense. Again, if you have questions, let me know. If I'm going too fast or if that doesn't, it didn't do a good, excuse me. If I didn't do a good enough job explaining it, let me know. Technically, this is a break and change. In the unlikely case that hidden layers were expected to be evaluated within modifiers, their visibility needs to be toggled. So, okay. That all makes more sense to me. Again, I'm not the best at grease pencil, but it sounds like a neutral change. It just sounds like a change to me. They had something that they hadn't intended to work, and then it did, but then they broke it. But it shouldn't be something that affects many people, and if it does affect you, they gave you a way to work around it. Cool. And then we've got some UI changes. Preview icon of locked materials is no longer grayed out. Neat. Again, I don't have a ton of experience, so that sounds like a nice UI change. They didn't gray out a thing when it shouldn't be grayed out. Fantastic. Properties of locked materials can be edited. Nice. And the dope sheet. Oh man, dope sheets. That's one of those things that I should stop talking about this because this is beyond my area of expertise. I thought it would be fun to look at grease pencil, but now I'm just getting into the weeds of things that I don't play around with a ton, so that's neat. There are a lot of good changes here, it looks like. We can play around with other categories of changes to Blender 4.4. It sounds, from what I've heard, I have deliberately not taken a look at any of these changes so that I could talk to you guys about it. But from what I've heard is that it's a pretty big change, like for modeling and things. Or maybe I'm just remembering 4.3. But yeah, that's a lot of what I wanted to talk today about. Were geometry nodes. What all has changed, what all is new, and now we can just kind of hang out and talk about whatever. I was kind of thinking about talking about game of life. That's a huge thing that I want to get some content out about, and I've been working on the video for that for a long time. Actually, let's just switch gears here for a moment because we're gonna pivot, right? But yeah, game of life, getting away from Blender 4.4, which maybe I should edit the title. I'm not 100% sure. Yeah, if we're gonna get into talking about Conway's game of life, because we've exhausted all of the geometry node stuff, why don't I add that to the title of the stream just real quick so that we can show new people that we've pivoted a little bit, right? And let me know if that sounds interesting to you in chat. If you'd want to talk about one of the projects I've been working on over the last several months. If you want me to give a demo of how it works and what I have built and how it functions, and how you can set up cellular automata in geometry nodes, because that's really what I'm going for, is how do we get, like, how do you do cellular automata in geometry nodes? I think that's really fascinating because we're not just tied to Conway's game of life. There are a variety of different cellular automata out there that we can play around with. But let me finish editing the title. No, I'm not going to do that. Yeah, there we go. Alright, Blender 4.4 and a game of life. Which is very exciting. I would personally love to talk about game of life and kind of just make it on the fly. I've made it a few different times, testing different ways to accomplish the goals of game of life. And I'll talk a little bit about what that is and how do we do it. Well, well, what it is, I mean, before getting into how do we do it. Because, yeah, Conway's Game of Life is so cool, and as I mentioned towards the beginning of the stream, that's kind of what we're looking at now in this graphic I have going on here. This is not Conway's Game of Life, but it is something inspired by Game of Life. This is a much more organic version that uses a variety of different rules to accomplish the same thing. But Conway's Game of Life is way more... It's a lot simpler. Simple and complex are... These are words that, like... I don't know, it's hard to gauge what qualifier to give Game of Life because it's based on simple rules, but that doesn't mean that what you get out of it is simple. And that's kind of the point. Conway's Game of Life, it's you've got just a few rules, and let me pull up the wiki for this. Just a few simple rules that lead to complex behaviors, and that's really the point. Now I want the wiki. So we're gonna go here. So this is Conway's Game of Life. We've got 4 rules. If I could hit the right button to scroll, there we go. We've got a few rules. And yeah, just a few simple rules that dictate how does this cellular automata propagate? Propagates, I guess, the right word. It feels weird to say that when we're looking at this. I guess this is kind of propagating, but this is kind of the pattern, an example of some of the patterns you can get from Conway's Game of Life, which are really cool. And I don't know, it's simple, but it makes some really interesting patterns. So the idea is that you have a grid of cells, right? And these cells are either on or off. Here the on cells, the living cells, are in black, and all of the dead cells are in white. And using these 4 rules, they determine, based on the cell's own state and all of the 8 neighbor cells in this square grid, what is the state of the cell in the next frame. So it'll turn itself on or off by having, if it is alive and has fewer than 2 living neighbors, it'll die. If it is alive and has 2 or 3 live neighbors, it'll live on to the next generation. And then if it's alive and has more than 3 live neighbors, it'll die. Oh, and also, there's another way to read these rules so that these 4 condense down to 3, which is why I wanted to stop at 3, but any dead cell with exactly 3 live neighbors becomes alive as if by reproduction. So, with all of that in mind, how do we do a cellular automata in Blender? First off, let's just get some geometry, right? To then drop our geometry nodes on, and we're actually going to get rid of the input, and we're just going to grab ourselves a grid. And the big thing here is everything's going to live inside of a simulation zone. And let me know if this is what we want to be doing, because I did say towards the beginning that we'd be taking a look at Blender 4.4. We've done that, but if there's more that anybody would like to talk about, then we can take a look, ask questions, let me know what you want to take a look at. We're just doing Game of Life because I feel like I've covered everything I wanted to cover, but if there's more people want to know, then I'm down to take a look. But okay, so we've got a simulation, and we want, well, first off, let's add some more geometry. So we need more points, and we're going to convert these points or well, this mesh 2 points. And that's just because it's easier to work with points. And do we want to, I guess doing that with vertices or faces, same thing. But let's go with 10 by 10 so that we can see this nice and clearly, right? And we want to store a named attribute. And we're just going to store a random attribute, right? And we're just going to say that that's on. So let's get a random value, and eventually we'll change this to be something more specific. Like we'll be able to input various specific patterns. Like if we go back to here, this little gliding pattern, that's actually called a glider, or a spaceship, I'm pretty sure. There are a couple of different terms for patterns like that that move. I like to call them gliders. But so right now we're going to input a random value, but eventually we'll take one of those patterns and input it so that we'll get little gliders moving along based on our design. So anyway, we'll leave that at 0.5, and really this is the important thing. And I changed my mind. I reserve the right to change my mind. We're not going to call that on. We're going to call that initial state. That's far more important to keep track of, actually. Instead of just, is it on or off? We need to know what the state is. And in the state, we'll say it is either on or off. So instead of changing the selection, we're going to set the value. And they have a 50% chance of being on or off. So if we take a look at this, we've got our initial state saved here. Fantastic. Now, in our simulation zone, what this will do is just run once per frame, right? That's simulation zone. But we need to we need to go through all of the rules for every point every time. So we're actually going to do a repeat, or can we do this with a for each element? I think we can do. No, we're going to use repeat zone. The reason is for each element has a feature that it isn't inherently obvious, but it joins all of the geometry together, which can mess up some of the calculations because we're not instancing geometry on each of these points. We're not really changing the geometry. We're changing the values and the attributes on the geometry. And for what we're doing here, it's better to do it in a repeat zone, or at least it makes more sense to me to do it in a repeat zone. You could probably do it in a for each element zone. But for now, we're just gonna run with the repeat zone. And what we want to do is find our neighborhood, right? Because each of these rules references the state of the cell and its neighbors. So the neighborhood pointing out on this grid, if we're looking at, say, this vertex, this point specifically, its neighborhood would be these 8 points surrounding it. So we need a way to determine which points are within that neighborhood. And the more technically correct way to do that would be to do index math and figure out, okay, if this is 0.0, that means any point that's in this row within this amount, or this column in this amount, all of those would be in the neighborhood. That's kind of the general idea of the logic. But instead of doing that, we're going to do a slightly less computationally efficient thing, and that's to find the distance between this point and that point. Which is very much not the efficient way to do it, but I have reasons for doing it this way. Those reasons being that we're doing this on a grid for right now, but I've been playing around a lot with doing Game of Life on various different topologies, so like doing it on a sphere or doing it across the surface of Suzanne. And that's far more interesting in my opinion, and it opens up a lot more questions. Like right now we have a uniform square grid, but okay, what if it's not a square grid and not even just a hexagon grid, but like an irregular grid, right? Suzanne's geometry is not regular. Like you look at her, we've got all kinds of different geometry going on here. We've got this point that has five edges, and then we've got most of these having 4. We've got whatever the heck is going on here. We've got a lot of different places in the grid that are ununiform, A-uniform, D-uniform, and so it interests me, how could we do a more generalized game of life? And that's what I want to build towards. But for right now, we're going to look at the grid just to get to the simulation set up. But that's why I want to do that with distance, because that is easier to play with an irregular grid and an irregular neighborhood instead of just doing the index math. Because just because this point is 0 in this setup doesn't mean on Suzanne the 0 index would be in the same spots as on a grid as on an icosphere, and they wouldn't necessarily have neighbors of 1, 2, 3, so on and so forth. So okay, getting more to the point, we're going to go to distance. We're going to take our position, and this is a field, so we want to sample sample, not nearest, sample index, there it is, because we want to take the position of specifically the point we're looking at in this iteration. This iteration is going to stand in for the index of the point we want to look at, right? So we're going to switch this from float to vector, and now we've got a single point, right? A single value. That's what I'm looking for, and that's denoted by this dot, right? This node or this socket doesn't have a dot, so that means that we're looking at every point in this field. This one's just looking at this one value. And now we can take that distance and we can check for a specific distance. And this is how we're actually going to find our neighborhood. So we need a value to adjust, and we need a comparison node. We want to see if this distance is less than or equal to some given distance. And we can hold on. I want to take a look at this geometry and this comparison node. Give me that. There we go. And we can see we only have 1 point. Right now we're defaulting to looking at index 0. But we can adjust that by going into our panel here and inspecting. I'm sorry. Oh, inspection index. Oh, I missed a step. Apologies. I completely missed a very important step. We need to know how many points we have to repeat over, because we want this to do this once per point. So we need to switch this to point cloud and then take the total number of points in our point cloud and set that equal to set our iterations equal to that number. So now this is doing once per point. We're going to do all of these calculations inside of the repeat zone. So now, taking a look at our inspection index, we can scroll through here and take a look at every single one. And because our value is set to 0, all of the other points are false. So let's just increase this until, hey, would you look at that? We have our neighborhood. Now, this is not terribly procedural, right? We just put in a constant value, but if the properties of our grid change, then we're kind of screwed, right? So as an example, let's bring in a value node here, set this to 1, and plug it into our X and Y. If we make this any bigger, yeah, our neighborhood will start to collapse, which isn't ideal. So what we should do, again, in the idealized grid situation here, is take... trying to think. We want to do a little bit of math. So we want to take our size and divide it by the number of points. Let's not get a value. Let's get an integer. There we go. Plug that in for both of our points because, again, right now we're playing with the idealized grid. So it'll be the total distance of, or the total length of this edge of our grid divided by the number of points that we have, and that should give us this value. Then if we just divide that by 2, oh, and yeah, actually change this to divide. That sure does help. So then we want to divide that by 2, multiply it by 2. I forget which way it's... I'm going to have to just think through this for a moment, because what we want to do is make sure that we are including our corners, right? Like, this is that distance. So if we just took that and plugged it in there, that's not even big enough. So we're just going to, yeah, multiply it by 2. That's... yeah. Switch that to multiply. Really? Geometry nodes, what are you doing? What did I... It doesn't feel like it's doing what I expect it to do, but honestly, that's fine. Divided by 2 again. If it works, it works. I was going to go through the formal math, but whatever, I want to move on. So we're just going to take half of the distance there. Half the distance, we've multiplied the distance. This, dividing by 0.5 is the same as multiplying by 2, if I understand my basic algebra. So I am baffled by the fact that multiplying by 2 doesn't give us... What the heck? Geometry nodes, why was your math inconsistent? Why did it... I swear, I just had it input like this, and it selected everything. Whatever, it's fine. We've got the distance for, again, our idealized grid. So now we have established the maximum neighborhood that we want to take a look at, which is great, except that's not exactly the neighborhood we want, right? So let's find our distance. Okay. The reason I say that's not exactly the neighborhood we want to find is because we're including the point that we have. And yes, we do want to know what the value of our given point is, but we don't want that in our neighborhood calculations, right? It just won't add up correctly. So what we need to do is do another comparison, and this time for integers, because we want to take the index of our given point and compare it to all of the indices, and we want to make sure that they are not equal. Then we'll get a Boolean math node set to AND, which is great because that's the default. Plug those two together, and now we have our neighbor excluding the point's self. Great. Fantastic. Save this stream, please. Yeah. Yeah. It should be saved, right? Like, it should turn into a VOD afterwards. I hope you're enjoying the stream. I don't know how long that comment's been sitting there, so sorry if there was any delay. But yeah, no, this should be saved on YouTube. No worries. Because, and I've said this before, I've actually done Game of Life before, but I did more of a technical how do loops work in geometry nodes, and then kind of used Game of Life as an example to show the different uses of both simulation and repeat zones. And at the time it was novel. We didn't have those nodes beforehand. And in that video I promised a tutorial on how to do Game of Life. And I guess that's kind of what we're doing now. Which is pretty good. I'll probably... I want to make a more formal video going through this in a more organized way. Right now I'm just kind of stream of consciousness, right? But I want to at least deliver on this information, because I promised over a year ago that I would make a tutorial on how to do Game of Life, so kind of doing that now. And I do intend to take this further than what I did last time we talked about Game of Life. Anyway, continuing on, we've got our self-check, and we've got our distance check. And there's one more thing we want to check, because I've been lying this whole time and we don't actually care about the neighborhood. That's not true. We obviously care about the neighborhood, but to be more specific, we care about the living cells in our neighborhood. So we want to do one more check, and that's to use not store, we want the named attribute. And we want the initial state. And again, to do a... Whoops. No, I've got a compare node right there. We want to do a comparison. Not into... yeah. No, we don't need to do a comparison. Excuse me, what am I doing? We don't need to do a comparison at all. We just need to make sure that this is true, right? Because our initial state is already a Boolean. We just need to make sure that that is true, that our distance is true, like these are within the proper distance. So zooming out, we're only looking at these 9 because we're also not looking at the self, and we're looking at the ones that are actually alive. And that's what we've got going on here. So this is our living neighbors. Cool. And again, a little bit of a lie. We don't even care about which ones are alive. What we actually care about is the total number of living cells in our neighborhood. Going back to the rules, we care about live neighbors in all of these rules and the state of the current cell. So, how do we get the total number of live neighbors? We use not a separate XYZ, no. Separate geometry node, plug our points into there, and we use this for our selection. So now if we take a look, we've gotten rid of all of the points we don't care about in this iteration, and we're going to once again do a domain size check. We're going to use the domain size node, switch it to point cloud. It's incredibly important. I don't think I emphasized this earlier. It's incredibly important that both of these domain size nodes are set to point cloud, because if you do this on mesh, this just isn't going to work, and you'll see these errors here because we gave it points and then asked it to look at this information on meshes. It doesn't work. So save yourself some headache, set this to point cloud. But okay, so that gives us the total number of points. So if we take a look at this and we take a look at that and we switch this to look at text, I wish I could make, I don't know how to make the text bigger on there, but that's a little 5 because we have 5 living points. And that's just a nice, easy way to diagnose, is this working or not? And so yes, it is working. We have the correct number of living neighbors for this cell, for this frame. And we can now finally get in to the actual rules of Conway's Game of Life, which is quite a bit of Boolean math, and excuse me if this takes a while to kind of get through, because Boolean math, in my opinion, is a little bit difficult to fully wrap your head around, at least quickly. It's not that I can't do it, it's that it always takes me a while to like think through it. But what we're going to do is get so many Boolean math nodes, and we're going to kind of break these rules down and combine them a little bit into 3 rules. So the first idea is we're going to see whether or not we have 2 or 3 living neighbors. The reason being that both of those situations say that the cell will continue to be alive in the next frame. So we're going to just basically use that to determine whether or not it'll be alive or not if it's already alive. If that made sense. Ask questions, make me repeat things if I just kind of word vomit and it doesn't make sense. But in order to do that, we need to know what the state is of our current cell. So let's do that real quick. We'll plug in a sample index node. We'll switch this to Boolean. We'll bring in another named attribute node. I could reuse this one. Nah, we'll reuse that one because I said earlier I like to reuse nodes, and I will live by what I said. But okay, we're going to use the initial state named attribute to look at our current index, but we need to know what the current index is. So we're going to take this iteration socket and pull that out over here along with our geometry, right? So that we can take a look at both of these. And now we have the state of our current cell. So we have that. We need a comparison node so that we can see how many live cells. Well, we know how many we have. We need to know whether or not that is equal to 2 or 3, right? And I would say greater than or equal, but we specifically want to know if it is equal to 2 or 3. So 2, 3. So if this or that is true, and it's alive, then it'll remain alive. Yes, good. Okay, cool. So that's rule 1. We're just gonna, I don't know how to label that offhand, so we're just gonna group that at the very least. So now, what we need to do is check to see, okay, we have whether or not it'll stay alive. Now we want to know, should it die, right? So again, whether or not it's alive, and if the number of neighbors is greater than 3, so we're going to go greater than, and is it alive? Plug this into that, this into that. Let me just step through the logic in my head for a second, because this is where I'm sure to get something wrong, just going off of memory. But yeah, we have total number of points. We want to know if it is greater than 3. And if it's alive, then it should invert, because if it's greater than 3, then it dies, right? So this isn't what we want to. Let's take a look at the rules real quick, so that we can see what the logic needs to be. Sorry, I'm trying to piece it together in my head and talk. And yeah, any live cell with more than 3 neighbors dies. Correct. Any cell with exactly 3 live neighbors becomes alive as if right. Okay. So we've already checked to see if it is equal to 2 or 3. We need to check again if it's equal to 3 and if it is not alive. So we're going to invert that and do an and I'm pretty sure you could achieve this same thing with like NANDs and XORs, but those ones get further into the weeds of Boolean math. I don't know if there's any efficiency to be gained, probably because you're doing fewer operations. So it's probably more efficient if you can figure out how to use the more efficient Boolean operators, but I struggle with that a little bit, and I need to not refresh, but I need to gain more experience and more knowledge on just Boolean math. But for right now, for legibility and understandability, we're gonna just do nots, ands, and ors, the simplest Boolean functions, because it makes sense to me, and I can talk through it. But, okay, so we have whether or not it'll stay alive, whether or not it'll reproduce, and then the fun thing about all of this is that I'm pretty sure if it is neither staying alive and it isn't dead and becoming alive, then it should either die or remain dead. So that means that if both of these are false, it should stay false. So we can just do another and that's all 3 of our rules in Boolean logic right there. We will find out in a minute whether or not this actually works. But we can go ahead and call that good, actually. Kind of, not quite. Because the next thing we would want to do is save this. But it's really tempting to just take our initial state. That is what I named the thing, right? Let's just double check. Yeah, initial state. I hate it when it doesn't pop up with all of the previously used attributes, but it's fine. So we're going to take... We don't want to do it this way, because what will happen is we'll override our initial state, and so when we go from point 0 to calculating point 1, instead of going off of the initial state, we'll do the use the changed state of the previous points in calculating this one, and things will just go wrong. It'll break, we'll get the wrong kind of simulation, it won't work well. So instead what we're going to do is change this to new state, and then we can go ahead and save that. And importantly, we're going to use a comparison, and just once again, we're going to make sure that we're using the given integer, the iteration number, which we're using as the index. We're going to make sure that these are equal, so that we're only setting the new state on the current point, which is really important, because if we didn't use the selection and we just set that for all of them, they would just constantly override themselves. They would change all of their new states to be index 0's new state, and then in the next one, all of the states would become index 1's new state, even index 0's. So it just rewrites itself in a way that defeats the whole point. So we have to make sure that we're only overriding the states on the given index. So now that that is set correctly, we should be able to just hit play. Let's make sure that we can look at either new state or initial state. Let's look at initial state, and we'll do this and hit play, and it doesn't work. Okay, what is going on? Naturally, the first time you do it, it's never going to do the... Oh, because I forgot a crucial step. Crucial. I just went on a whole rant of don't override the initial state, right? Don't override the initial state, and don't override the new state. But that's only while we're within the repeat zone. Once we get outside of the repeat zone, now we want to take our initial states and override it for all of our points, so we don't need to worry about selection. We want to override it with the new states, and we can not into selection, put that into value. So now we can do that, and sorry, I'm just trying to get the initial state pulled up here so we can take a look at that. Why? What are you doing? I go on this whole spiel about how simple this is, how this is just gonna work, blah blah blah. What broke? What isn't working correctly? It's got to be something in this area, right? Because, oops. Taking a look here. Let's step through all of our points, okay? And debug, why isn't this working? So let's select the repeat zone. We're gonna go to, index 0. And if we step through, okay. Well, darn, I must have messed up this Boolean logic. So give me a second while I pull up Blender 4.3 where I made the previous version of this, so I can reference my notes instead of spending a whole lot of time trying to think through something that I've already solved. We're going to just skip to correcting whatever mistake I have made by just kind of riffing off the top of my head. It's just going to take me a hot second to pull this up. Project files, game of life, pull up the most recent version, and let me just take a moment to look through and compare. Oh, yep. Okay, I see where I messed up. This shouldn't be an AND node. This should be an OR node. And the reason being, if it were an AND node, it would need both of these to be true in order to return true. And these are mutually exclusive. Because these are mutually exclusive, which means that they will never both be true. We need this to be an OR, so that if this or that are on, it'll stay on, meaning like it'll stay alive, and then if both of those are off, then it'll die or remain dead. That's the thought process. So, with all of that out of the way, this should work. Yes! Okay, there we go. We have Game of Life. It's not very interesting at the moment because it's moving incredibly quickly. We have a random pattern that is not guaranteed to give us anything interesting. We can turn up the amount of points and maybe we'll get something interesting. But it is doing very familiar Game of Life patterns. It is functional. It is working. How do we make this more interesting is now the question. I'm glad I got that to work in only one minor little thing that I couldn't do just from memory. I'm pretty sure I've made that little mistake before, but anyway. The first thing we want to do is slow this down a little bit, right? Because watching all of these blinking lights, while it's great, it's a proof of concept, it's not the most interesting and it goes way too fast. Actually, I kind of want to just, well, let's not turn down the probability. Let's just give it a different seed and watch something different happen. That's a lot better. You get those patterns of like it goes off this way, something breaks off, it becomes stable, it goes off, comes back, interacts with it. It's very fun, very neat. This is why I love Game of Life. You get all of these different emergent patterns. I love emergent behaviors. They're my favorite. So okay, we've got that, and now let's slow it down because that goes way too fast. And yeah, it'll most of the time get when we just input random noise, it'll get to a point where it just stops, right? But we want that to take more time. We don't want it to go so fast that we have all of this additional time in the timeline, right? So how do we do that? Let's first get a scene time node because we want to work with the frame number. And kind of similar here, we're going to only run this simulation every nth frame. There are a couple of caveats here with that. First off, we can't really use this skip input. If we do, it breaks the sim, and in ways that I don't fully understand. I can't give you a technical deep dive as to why that happens. So instead, what we're going to do is compare our frame to a given value, and if they're equal, then we'll actually store the initial state. Otherwise, we're just going to move on and not actually store it, which means nothing will actually change. That does mean there are a lot of things that, well, no, it doesn't actually process anything. Blender is smarter than that. Blender, because of back feeding? I forget what the actual term is, but we read nodes left to right. Blender reads nodes right to left, which means that when it starts at the output and gets back to this node, if we have this selection set so that nothing's actually being calculated, it'll go cool and not calculate anything and move on to the next frame, which is fantastic and efficient. So even though it may sound like it would be more efficient to skip the frame, and it might be mildly, it breaks the sim, and by putting in the selection, telling it with the selection input here when to calculate things and when not to calculate things, we get just about the same effect. So, all of that said, let's get our comparison. Let's also get a value, because we need, well, we don't need a direct comparison because we're going to actually take an integer. And I say that because we're actually going to get a math node. We're going to take a modulo and say, let's just plug in 12. Every 12 frames, it'll calculate this. So we want modulo to equal 0. Sorry, I'm getting ahead of myself and not actually thinking through what I'm doing. That's not correct. We're going to take the frame and mod it by our given number. Yeah, I was talking faster than I was actually thinking and doing things. We're going to mod our frame by this, which means that then every 12 frames, this will return 0. And we can see that, well, it'll equal 0, and then this will return true when this returns 0. And we can see that, yeah. Oh, I have it set to greater than. I'm like, why is... That's doing the opposite of what I just said. Yeah, because I had it set to effectively the opposite. So this will flash every 12th. Yeah, and I shouldn't be doing that flashing. We'll zoom out so that there's not so much strobe. I'm sorry, I didn't think through that. Apologies. But yeah, every 12th frame it's flashing. So that's the frame rate that we'll be running the simulation at, if that makes sense. So now we should be able to take a look at our geometry. Once we plug this into our selection for saving our initial state, now we should be able to rewind, taking a look at the initial state, and now every 12 frames it does a simulation loop, and we get a much slower game of life, which that's a value that you can tweak, right? Speed it up so that you can see more patterns faster. Like, if you want to zoom out, have more points, you probably want to watch it go faster because there's just more going on, right? But if you're just looking at a little bit piece here, I don't know. I think it's more interesting if you slow it down to a point. You don't want it to go too slow, but you want to slow it down so that you have more time to appreciate the differences between the different ticks, as it were. If that makes sense. I hope that all makes sense. I might actually speed that up a little bit. We're going to change that from 12 to 6. And now it plays a little bit faster, which is really nice. And cool. That is your very basic game of life setup. Now we have a little bit more time. We could go into some stylization of this because, well, it's neat. We could either go into stylizing this, like instancing points, animating points between these, the initial states and the simulated states, because you can get some interesting animation with like float curves to animate the position, the glow, the color, so that you get more visual variance between each state, and it's not just a robotic tick between the different states, right? Or we could talk about the more theoretical what's going on and how do we generalize these initial parameters, like the distance that we're checking for or the rules that we're going over, to accommodate ununiform grids. I talked about this towards the beginning of setting up this simulation, but like, how could we get this to run on Suzanne, who doesn't have a uniform square grid? So we could do either. I have about an hour before I really need to wrap up the stream, but we could talk about making it look pretty or some of the more hypothetical stuff. I think we might make it pretty if nobody in the chat wants to do the opposite. That's up to you guys. I'm terribly sorry, I just bumped the mic. I hope that did not, I hope that wasn't an unpleasant audio experience. But okay, let me know if you guys want to pivot to the other one at any time, but for now, let's take a look at how do we make this more interesting. So we can, of course, instance things on points. This is just kind of like, how do we step through making it more interesting? So let's instance things on points. Let's get in a cube, and we're going to get the radius, because if we just instance in a cube, well, like, get rid of that, we're gonna get this block of Z fighting, which isn't great. Instead, we're going to scale that down by the radius of each point, and we could take our distance value and use that to set the scale. That's fine. We don't need everything to always be quite so procedural. We can just manually affect the radius here and get it closer to something that looks nicer, right? So now we have a grid of cubes. And of course, if we hit play, we see nothing because our initial and new states are just that. They're just states. It's just an attribute. There's nothing actually going on here. So the easiest thing we could do is just do a combine XYZ node and take, yeah, sure, our initial state, plug it into the Z and use that for position, but we can't do position on instance to points. So what we're going to do is set, not material, set position and use the offset. But of course now, because this is 0 or 1, they're flying off into space, so we're going to use a math node. We're not going to add. We're going to multiply by 0.5 or point, really whatever, like 0.1. We could actually even have this inherit from radius. How's about that? thinking smarter, not harder. So, we've offset these in the z-axis, and if we hit play, we've got them animating, right? But there's nothing interesting going on here. What we want to do is maybe interpolate between the off state, the off position, and the on position. So we need some way to figure out from the initial state and to the new state, what are the different combinations of those states, right? Like, it's not just interpolating, okay, you were here. Well, it is interpolating between you were here, now you're gonna be there. But there's just more to it than that. We need to compare all of the states, and the best way that I have for doing that is just literally a list of compare nodes, which isn't the most elegant, but it's fine. What we'll do is we'll take our initial state, and because these are integers and booleans are, so long as you're just looking at zeros and ones, interchangeable in my opinion, we're just going to leave them as integer. Also, we don't have booleans in this list. So we're going to look at all of these combinations, and we need to know, we're not comparing the initial state directly to the new state. Instead, we want to know if the initial state was off, and if it's become... Give me a hot second. I gotta think through this before I say it. Otherwise, I'm going to just keep re-saying the same thing and make it progressively more confusing. We need to know if the initial state was off and if the new state is off. We need to know if the initial state was off and the new state is on. There's a lot of comparisons here. We're just kind of rolling through it. Then we need to know if the initial state was on and the new state is on, and we need to know if the initial state was on and the new state is off. That should be not just like every combination, but also the order that things would kind of go through, if that makes sense. And since I have the other version of Blender open, let me just make sure that I'm not going way off into the deep end of what the heck is going on here. Oh yeah, no, I'm way overcomplicating things. Just thinking through this on the spot. Apologies. We're not going to... There's a much... That would work. That would absolutely work. But it'll create a lot more work and a lot more nodes, and you can see how big this is getting and how much is going on here. No, we don't want to do it like that. Instead, I'm gonna just kind of copy-paste some of the nodes from my old project, and then we're going to talk through it. Because one of the things that I have going on here is we had comparison nodes, and that's for comparing integers, and I was talking about how booleans and integers are a little bit interchangeable, but it's actually easier if we stick with booleans for a moment before then converting into integers. I was trying to convert integers into booleans. It'll make more sense once I get it all laid out. So, going through the same logic I was just talking about, we want to know if this is on, or sorry, if this is off. So this will return true if this is off. And if this is on, because both of these being off will be implicit. You'll see what I mean in a moment. We want to know if both of these are on, so these should both return true, and then that'll return true. And then we want to know the opposite. We want to know if it's initially on, and then turns off. These are the three parameters that we have to work with here, which is so much smaller than what I was about to set up, which had all of the complicated explicit logic. This is so much more condensed. Booleans are great if you have the ability to think through all of the different ways to get to what you're working towards. Anyway, this will give us basically 4 options for the 4 states we're looking for. Are they both off, which is implicit and we don't have a node for? Is it off and going to become on? That's what this one will return. Are they both on? That's what this one does. And then is it on and then going to turn off? That's our last option here. Okay, now we can get some comparisons. And let me bring up the chat again just to make sure I'm not missing anything. Because I'm looking at my notes instead. So, okay. Now we're going to do our comparison. No, we need a switch. Excuse me. We need a switch because these are going to be the booleans that turn into an integer. We're using a switch to do that. That doesn't make sense right now. I'll explain it once we have it written out. So let's get a switch in. We're going to switch this to integer. And we need 3 of these. What these are going to become are the integers to use for an index switch node. So let's pull in our index switch node. And we want this to be a float, I'm pretty sure. Yeah, and we're not quite there yet either. So we've got this switch. It's going to be either 1 or 0. Sorry, it's always the Boolean math that just... I really gotta think through it. Okay. Right. We're converting combinations of Boolean options into integers. We want these integers to line up with the index of different options we're going to calculate. So we want 0 to be implicit. That's just going to end up being 0. We want this one to be 1. We want this one to be 2 if it's true. If it's false, it's going to be 0. And if this one's true, it's going to be 3. Okay. The reason we're leaving false to 0 is because only one of these is going to be true at a time, which means that by telling them this Boolean to become an integer effectively, we can now add these together with a chain of add nodes. And so what happens is if all of these are false, these will add together all being 0, and we'll get a 0, which means when we plug this in, we will get our 0th float value. When the first one is just on, when it's only the first one on, we will get 1, the rest will be 0, these will add together and become 1. Same thing for 2, these will be 0, we'll get a 2, and 3, etc. So, with those all going into our switch, we now have floats that we're able to animate. I'm sorry, a lot of this is going to be kind of theoretical, and it'll be a minute before we're able to actually apply it to our geometry. So I'm trying to explain things as best I can as we go, but it may not click until we see what's happening. So we've got these 4 different values, which means we have, now that we've sorted out all of the combinations that we can possibly have, we're able to take some float value to use to interpolate between values. Again, it's very theoretical. I need a second to put it together. Uh, because what we're trying to do is change the position from one value to another value, right? That's what we've got animated right now. I want to animate across the frames where it's just in one state or another state, so that we have a nice animation. So we need some time value that we can use to interpolate between those two positions, if that makes sense. Here we've broken up our time into segments of 6 frames. We're gonna increase this all the way up to 24 to give us more frames to see this animation. But let's just copy that real quick, and instead of going into an equal, we're gonna get rid of that and use a map range node, so that we can take basically our frame. We're going to floor it, so now we've got kind of a jagged looking time graph. We've got values increasing from 0 to 24 and then dropping back to 24, and increasing and dropping back to 20, or dropping back to 0 because it equals 24. We're not going to clamp this. I guess we could clamp it because we want the output to be between 0 and 1. So, okay, we've got the clamped time, 0 to 24, and then we're going to take that range, 0 to 24, and convert it into the 0 to 1 range. Now, we can use that kind of as the driver for a float curve. Yeah, there we go. So every time we run through that loop of 24 frames, we're going to have a value that increases with whatever we have graphed in this float curve. So right now it'll be linear, so it'll just kind of look like it's increasing from 0 to 1 every 24 frames. We could give it something that looks like this, and now it'll increase from 0 to 1, but it'll increase more quickly. It'll accelerate as we go from 0 to 24. I have some animation curves that look better, but for right now, what we're going to do is just kind of do that, and we're going to do that, so that we get a value that we can use to offset the position, which is way up here. We're basically going to just get rid of that and drag this down here to go into the index, which we're going to plug these into here. This is incorrect. We want to do this. Again, I'm sorry. Once we get it put together, I'll explain it more thoroughly. Gonna do that into the third one and turn this onto 1. Okay. Okay, what is happening? We've got these 4 options, because again, 0 is implicit. We've added them together, so we have an index that is 0, 1, 2, or 3. If it is 0, we want this value, which is changing with time. It's changing over time, always going to be consistently changing over time, but we're going to switch between which one we're looking at. So if both states are 0, this value is going to be 0. If both states are, or if it transitions from 0 to 1, it's going to increase the Z position using this float curve a lot through time. If both of them are 1, if it was alive and it's going to stay alive, it's going to stay at 1. And then if the float curve is, yeah, if it was alive and now it's going to 0, it was on, now it's going to be off, we're going to use this curve to do a fall off here. These are not going to be pretty curves, but it's what I've thrown together right now. And I guess the last thing would be, yeah, we need to once again multiply this by our radius. That's what we did up here, right? So we're going to grab that again, and instead of, has the playlist sorry, just the talking is messing with my thoughts in my head, so I'm just like, let's skip that song. How's about? There we go. Okay, So let's multiply by our radius so that we're not scaling all the way up to 1. And now we've got all that animation happening right here. And hopefully that makes sense. Again, please ask questions in chat. I'm happy to take more time to explain something, but we should see, yeah, okay. We've got the animation I was looking for. Like I said, those curves, not going to be interesting. I have more interesting curves laid out in my notes. So we're going to just modify these very imprecisely to be more akin to what I found to look very satisfying by doing this. And you need to be interpolated this way. That's also not going to be terribly pretty, but it's fine, right? Yeah, so long as you don't go negative. Don't go negative. Yeah, there we go. Now it kind of like slides into up and slides down. Like, I don't know. This is more satisfying to me. So yeah, that is super simple. And we can get more complex with this. Like, we've got a little bit more time. We can make this look pretty. So we're going to make it look pretty. Well, what do I mean by that? We're going to store some named attributes. Hi, I'm not sure if you're aware, but you can only hear for... Yeah, I was told early on in stream. Apologies for that. I am aware. I was also asked to just kind of move on because I was having a hard time figuring out that technical issue. If you don't mind me taking more time to figure it out, I'm more than happy to. But I was asked to just kind of, like, let's not waste time with that. So future streams, we will fix the audio issues, okay? For sure, we will fix the audio issues. This time around, I'm terribly sorry that my audio is only in the left ear. That's really bad. But it will be fixed for next time, I promise. And thank you for letting me know, because I do want to know, right? And yeah, if it's super bothering you, I can take a minute, but not hearing that, I'm going to continue to get into some materials, right? Let's talk about materials. So we're going to store this interpolated value for our Z. We're going to, what do we want to call this? We're going to call this Bob, because I can't think on the fly of a poignant value for this. But now that we have saved that onto... No, I'm about to make a big mistake. Don't let me make this mistake. Don't save that there. We're going to save this on our points before we instance our geometry, because I don't think we can save attributes. Okay, we can save them on instances. I take it back. Save it wherever you want to. The more important thing is that when we switch to shader editor, after we bring in a set material node, always bring in your set material node and create materials before you start playing around with materials. Oh no. Oh no. I created a new material and we're set in cycles by default, I'm pretty sure. That's how I've got my preferences set. So, and I'm streaming. We're gonna see if this crashes. Okay, cool. Great. Whew. That was scary for a hot minute. Hey, we're just gonna let me save this because I haven't done that. Save your projects, kids. Don't follow my example and wait 3 hours into a stream to save. That's not smart. Alright, Game of Life stream 24. 0324. You're good at. I fixed it on my end by making the audio mono. Ah, you can adjust it for next stream. Create tutorial pathway. Thank you. I'm glad you got it fixed for you. I will make sure it is fixed for everyone and for the VOD next time. Sorry for any inconvenience. Thank you for going through this with me. You know, and I'm glad you're enjoying the tutorial. I'm glad you're having fun. It was interesting when we switched from talking about Blender 4.4 to talking about Game of Life. There were several people here chilling, and then I saw a big dip, and I'm like, yeah, that's fair. That's fair. But I'm glad you're enjoying the tutorial. I'm having a lot of fun talking through this because I've wanted to talk about Game of Life for a long time. Because it's neat. I've wanted to show how to do it. I haven't been able to finish that video, so now we're just getting it done and out there. I still intend to make a cleaner video showing how to do all of this, but at least at the end of today, all of this information will be out there for the public, and that's my goal, right? Anyway, let's save that. Finish saving that, because I can't walk and chew gum at the same time. I have learned throughout the course of this stream. Anyway, this is saved. Now we can create, we're gonna call this Game of Life, because I can't think of names right now. We're gonna set the Game of Life material, and now we're going to go into the shader editor. All right, let's go. We need an attribute node. We're going to change this from geometry to instancer. Huge thing. I cannot overstate this enough, which is why I'm full pause right now. Change this to instancer, because if you don't do this and you're using instances on all of your points, this will not work. Okay? But now we can, what did I name this? Hold on. What is the name that we gave this attribute? I know it was something silly. Bob. Right. Okay. We're gonna make sure we reference Bob. Bob the instancer for our attributes here. So, okay, we want... Okay, there's something more complicated we can do in a hot second. Right now, we're just going to show that this is working in our materials. So we're going to get a hue node, easy way to take our factor, which is our float value. We're not putting that into factor, we're putting that into hue. We're going to make our hue something like this, and that'll just show that we have something going here once we... Again, I'm going to save, because... Oh, excuse me. Inevitably, when I switch to material preview, it's going to take a minute. Okay, thank you, Blender. You're fantastic. That's not a large enough contrast, so we're going to multiply that by 2. There we go. Cool. Now we can see the transition from one color to another as it goes, which is fantastic. And, crucially, we're not going to multiply it for this, but I'd like to have some emission, so we're going to plug the factor into strength, and you can't really see it here, so again, saving, we're going to switch to fascinating. Okay, why don't we have any emission? Oh, we're not in EV, or I'm sorry, we're not in cycles, we are in EV. We're going to go to GPU compute, and we still don't have much emission, so let's, maybe we do multiply it by 2? Yeah, okay. Yeah, we'll multiply it, but we're gonna crank that so we can actually see it. Something ridiculous, something crazy, I don't know. This is not a materials, this is not a shader tutorial. I'm just showing you guys some things that I've made that sound good. Most heart attacks when we change material. True! Oh! Yeah! Oh, so many times I have crashed Blender, not because I switched, but because I switched, it paused, and I went, oh no, oh god, what did I break? And clicked a bunch, which is such a rookie move. And then it really freaked out and took even longer. I don't think I've actually... No, that's not true. I've definitely crashed Blender by doing that. It's less common, especially since I added more RAM to my PC. But, oh man, it's a time. It's an absolute time. But yeah, so we have multiplied this. We've got glow, we've got color change, we've got it offsetting all of the position. There's a couple more things I want to do that will basically get this up to the version that I have going on in the video that I've been working on talking about all of this. That'll talk about this in probably a much drier tone, but also with more graphics. So that'll be fun when I get that. I'm gonna say publicly so that I actually end up doing this by the end of the week. That video will be done because it is 90% there, and I just have to finish it. And now that I've said publicly, it'll be finished, and my patrons will get it sooner. By the way, not that you need to pay for this. It will be available for free on YouTube. They will just get it sooner. Don't spend beyond your means, but if you could support me, I'd appreciate it. Anyway, shameless plug. Let's get this rounded off, yeah? So we've got all the things. I've already said that. We've got it doing all of the parameters I wanted it to. Let's just make it a little bit prettier. And the way we're going to do that is by adding in some temperature. So we're going to use this black body node. If you're not familiar, this was introduced in Blender 4.2, I want to say. So it's been a minute, but it was the last time I actually talked about a Blender update on this channel. So yay, we're back. We're back at it. I promise. What we're going to do is we're going to not call this Bob. We're going to call this Steve. No, we're not. No, we're not, actually. What's, you know what, I'll do the actual streamer thing, and hey, Atomic, you're gonna, welcome to the blend file, bud. Thanks for being here. Sorry everybody else, Atomic was in the most recent comment. I can change Bob if somebody else would like to be Bob. That sounds weird, and I'm sorry, I'm just having fun. Anyway, the point is we're going to take black body, which is going to take a float value and convert it into a color. And it does that based on physics. Instead of doing that with like a color ramp, and I bring this up because I said it'll take a float and turn it into a color. So we'll color ramp, but it'll do it however you choose to do this. What black body does is... 1 second, I'll read chat. I want to get this thought out of my head. What black body does is it takes physics concepts and it turns it into black body radiation. Wonderful Veritasium video talking about that. But essentially, it's like light colors. So I have this light. This is actually really convenient. I can change the Kelvin, which is the light temperature on this light, and it'll turn more daylight or more warm, like more cool or more warm. Warm is cooler, in fact, and cool tones are warmer. It's neat. Physics is wild. But we're going to use black body to actually get some values, and these values need to be multiplied to be large. Anyway, I'm sorry, I just needed to talk about black body for a hot second, but I saw some chats. So, what GPU are you using? I am using a... Oh god, that's a great question. It's a 1660 Super Ti, I think? I don't know everything about hardware, but that's the one I've got. It's not the highest end GPU, but it's reasonable, I'm pretty sure. At least it was when I bought it. When my wife bought it, let's be honest here. Props to her, she's wonderful, and I love her. She's an engineer, so she financed my PC, and I just credit where credit's due, right? Anyway, that's a whole aside. What we're gonna do We're not going to use an add node. What am I doing? No, we're going to use a map range node because we have a value coming in between 0 and 1, and what we want to do is we want to change this to a value that's much larger, because black body radiation, Kelvin, it's a much larger scale. So what we're going to do is, if I remember these values correctly, we're going to go from 5,000 to 7,000, and that should work. So going back into, not the compositor, I keep going to the compositor, into the shader editor, we're going to get another attribute. We're going to go atomic, and we're going to grab the color and plug that in, and there we go. Okay, so all of these are off, but when they go to animate up, they'll kind of turn like a red before turning into this like warm white. So let's kind of an orange. Let's go into preview. You won't be able to see the glow so much, but you should be able to see the color. Hold on, wait a minute. We have global parameters here. Let's turn the world brightness. Yeah, no, that's not going to help in preview. Yeah, we can see it more here. Sorry, I'm trying to make sure that you guys can see what I've actually changed, and I promise, like, it'll look better, but at the moment it's not really showing much of a change. So yeah, I've had it look much more. I know what's up. We've cranked the glow amount, so that needs to be less. I swear it's changing color, or maybe I just haven't plugged in an extreme enough amount of color. Let's pull up the notes once more, and I'll remind myself what colors actually looked good. 1,000 to 5,000. Okay, I've got it way too warm. So, my bad there. 1,000. Yeah, now we're looking at the red I expected. 1,000 to 5,000. Really past Gavin? That's the color range we went with? I'm not sure I agree. Perhaps I do need to switch that to instance. Nope. Nope. We're good. Weird. Yeah, I know that color has looked better. Why are you like this? Or maybe I just need to adjust some of the material. Let's bring up the roughness, so at least we've got less of that. We've got no metallic. Yeah, that's wild. It looks... Okay. Spoilers, I suppose. But, like... Let me just show you what it's supposed to look like, because I'm not sure that I'll be able to just kind of figure it... Like... I'm sure I can figure it out, but I don't want to waste everybody's time with just tweaking values and seeing what looks good when I'm just like, oh, let's just make it look nice. So this is the version that I've already made. Are we in Eevee? We're starting off strong. We're in Eevee. There we go. Yeah, and that's more what I'm going for, is like you see it turns red there. And by the way, this is a whole complex. I have got a whole setup just on like instancing gliders periodically as this goes. It'll be fun. Here in a second, more of them will pop up here. Ooh, subsurface is a good idea. We'll look at that in a hot second. But yeah, gliders just kind of appearing out of the ether. Where was it that they appeared? Yeah, this was really fun to put together, and just have a brigade of sliders going on and then collapsing there towards the end, because they'll hit the wall and then havoc. But anyway, yeah, getting back to the point, we've got this color kind of coming in. They start off looking black and then this. So yeah, let's take a look at the subsurf. And yeah, maybe, like, I don't think we've got... Subsurf is one of those things where I know the theoretical idea, but actually tweaking the values gets a little beyond me. It looks like I've got the same values set up. Yeah, weird. I even had 0.5 there for the roughness. Let me just take one more moment, see if I can show how this looks. Like how to get to the prettier version from here. So what is the node setup? I guess I can show you guys. I've already shown you guys what we're looking at. So we've got, and I know this is instance, but that's because I stored these after instance deployments, so we're doing the same thing here. But yeah, 0, 1, like all of that's feeding in here. Got this from 1,000 to 5,000 into black body. That gets fed into the color. Also, I think the glass morphism material would look great in this. Ooh, glass. I'm not sure exactly what material you're referencing, but like a glass, like I'm imagining you're talking about like transitioning from like maybe a metallic to like a glass, like it becomes transparent, translucent. It does glass. It's not just alpha stuff. That could be really cool. That would be really cool. That would be fun. I should play around with that. Actually, that's a good point too. Another thing you could do is have this transition. We've just got this doing a principled BSDF. But what you could do is bring in another material and a mix shader, and then have basically this parameter be the factor for transitioning from one material to another. That would be very cool. It's not what I've got going on right now, and I'm not sure what materials I would transition between, but very fun idea, and I will definitely play with that in the future. But yeah, I'm sad. I'm sad that that's not working. I'm glad we've at least got the color, we've got the emission. It's got to be something about the reflectivity here, because if we look at the material preview, like these, also, yeah. Sorry, I'm just thinking about color. I'm looking at this. I'm like, why? It should turn to black. Why isn't it turning to black? Do I need this to be set to geometry? No, I'm gonna switch the order of these two nodes to be over here, and we're gonna switch them to run on instancer and see if that actually is the problem. Because even though I know what I'm doing, right, sometimes there's just one little technical detail that's buried in there that doesn't play the way you expect it to, and it's like, why? Why are you doing this to me? Instance. Okay, we're gonna get rid of that. And we don't need any of that anymore. Whoop, nope, we need that still. We don't need these two, because we were using them for something else, but we do want this radius to set the scale. Okay. Now, we've got to find, we've got this value, which we don't want going through the map range. Oh, we're multiple. Oh! Okay, I found it. I figured it out. Okay. Let me reset this. We're not going to switch them around. I just need to make sure that these are set to instance, and they are. Okay, I figured out what the heck is going on. It's because we were multiplying with radius before running that through a map range node. What we really want to do is take the multiply and set that for Bob, and then we're just going to take directly from index switch to run into the map range node. And this is why I was trying to keep things organized towards the beginning of the stream. It's getting a little chaotic down here, but index switch directly into map range, directly into black body, because this is 0 to 1. This was no longer 0 to 1, so it was being weird. I think we're good. I think this will work now. So let's switch back to here, and we've got no glow. Hold on. I still broke something. Yeah, instancer. Do we need to crank the glow? Do we need this, No. Nope, I just need to separate. I need to label everything, I need to separate everything. This radius node, really this multiply node, messed the whole thing up for me. If I hadn't been pulling from the multiply node, everything would be fine. This is only for setting the position. In fact, yeah, set max position. Okay, that's what that does. Then we get a map range for our black body, temp and color. And then, yeah, this, Bob, you just need to be 0 to 1, and then it'll work. It still looks a little weird, and I think that's because we've got that metallic, or maybe the subsurface is all the way off. I don't know what the heck is up with that. I think we've just... Yeah, I don't know. I don't know why it's reflecting so much, but that's also not the worst thing in the world. It was more that it was like the colors were a lot closer than I wanted them to be. I wanted these to be closer to a white, and these should be black, but right now they're on because they're reflecting a lot of color, not because they're emitting color, if that makes sense. So it looks neat. It's not exactly what I wanted, but it's a lot closer to what I was showing you in the older version. That's pretty good. And maybe if we just take this and turn it down a little bit, then yeah, we're losing that color there, but it's more apparent that these are in fact off, right? So yeah, it's not fully refined, and I don't love that we've got a lot of bloom there, but like, that's what I set out to make. And I knew it wasn't going to be as polished or refined as the original version that I made for a video, but this is pretty good for working on just live, right? So yeah, that's it. And I'd be down another time to look at the more theoretical sort of thing. The theoretical, like I was talking about, I've mentioned a couple of times, working on regular grids, not this perfect square grid, but things like hexagons, things like organic meshes, any grid that doesn't have uniform neighbors. I have worked out how to do that. I have managed to do that. But I'd be happy to talk through that another time if you guys would like. But I think, really, without further ado, that's that's pretty much it here. If anybody has any further questions, I'm very down to keep talking at least for a little bit, but that's all I had prepared for today, if that makes sense. So, really, I can't thank you guys enough for being here. Uh, let's switch back to this cam so you guys can see me a little better. And we can take a look again at this little graphic. That might also be something that we do, not next time. I want a little bit more build up before talking about that animation because I'm really happy with it. I'm really happy with it, and there's a lot that's going on there, and it's, again, inspired by Game of Life, but it is more complex than Game of Life. And it makes me really happy, and I can't wait to show you guys how I made that, and also how I plan on building on it. I want to do a lot of life sims, by which I mean like cellular automata, like Game of Life. Is it possible to use this exact animation but replace the cubes with a custom mesh? Oh, absolutely. Let's, yeah, before I keep rambling. Yeah, let's, switch back. Yeah, so I have, where is it? Here. I think we're just instancing a cube, but like, we could either get the new geometry nodes, object node, and then an object info node to reference anything else, but really what I would say you should do is use a group input node and then put an object in there so that if we go over to the parameters here, we can input to that as our instance instead of our cube, and since there's nothing, we're not going to see anything, but jumping out of render mode, let's say, instead of just showing you some default geometry, like some regular geometry, like I was going to instance a sphere, let's instance a monkey. Try it with Suzanne, maybe. Exactly, we're on the same page. And in fact, we're gonna just give her some subdivisions because she deserves subdivisions. I don't know. Shade smooth. Now it looks a little bit better, right? And what we're gonna do is turn her off so we don't see the model itself, but we're gonna switch back to the plane and grab Suzanne. And now we have a whole bunch of monkey heads. Would you look at that? And we're actually going to get rid of the radius and just get a value here because I want to adjust how big she is. Yeah, and why don't we... Sorry, now I'm just going to play around for a hot second. We're going to... Yeah, why don't we rotate instances since we've already got these all rotated. I want a random value. Can we get a random float? No, sorry, random rotation. No, we cannot. We're gonna get a random float, combine it into a vector, and then we're going to rotate. Vector rotate, I think that it. This is great, thank you. Absolutely. And I'm just having fun at this point. Like this, I can animate and we'll watch it. We'll just watch it go. Watch all the Suzannes go while I figure out how to rotate. Rotate. Axes to rotate. That's the one I wanted. Okay. So, is this the one I wanted? Maybe. Nope. No, it sure isn't. What's the node I'm thinking of? You would think I would have all of these just in my head as in a dictionary, and for the most part I do, but like, I want to not axes to rotate, not vector rotate, Euler to rotate, maybe, hey, maybe, and maybe I just don't, yeah, okay, that's my problem. Do I want that in radians? I think I want that in radians. Yeah, because we turn that down, we don't get a ton of... Yeah, that's the full range of which way are they facing. And now we have just a whole bunch of randomly rotated, hovering Suzanne heads. Oh, shoot, wait, hold on. Wait. We can... sorry, I'm trying to think. Let's animate this, just because we can. I'm gonna go overtime now, just because we're having fun here, right? Let's take our random value. We're going to add... Not that. I do that every time. I type in frame when I want the frame, but it's scene time. We're gonna map this from... we can plug in whatever the heck we want. And we're gonna do that. We're gonna multiply this. Sorry, I'm not exactly explaining what I'm doing, but I'm thinking like we convert frame into a radian, and then we can multiply this so like this will spin twice, and if we add those together, then we can add that to our Z, and now they... Now then we have spinning Suzanne heads animating in a game of life. Let's... Okay, we've got this node. Seriously, if there's anything you want to ask, just stop me, because now I'm just kind of stream of consciousness playing around and having lots of fun. This is what I like to do, is just mess around with this. So I've taken the one value node that we have, and really I should have this in an input, a group input, that would be better, but anyway, we have one node controlling the frame, the tick rate of this simulation. So if we reduce that, now they're really flying. Let's maybe go with 12, and what I want to do is, we've got this multiplying, let's get another random value. Sorry, one of the things I love doing is just taking, like, I set up a whole thing that does something theoretical. Now let's see what are the knobs and levers and things, all of the parameters we can just, like, use to control it, to just do whatever the heck we want. So like we've instanced Suzanne's. If I had a list of different geometries that would be interesting to instance, we could have a bunch of different things instanced. And I guess now I'm just kind of doing like procedural modeling 101, where we just start throwing things together, right? Anyway, we've got random value from 0 to 1. We're gonna go 0 to 1 is fine. And we're gonna use that to multiply, so now they're all spinning at different rates. We can increase the max so that, yeah, that's fun. And we could, instead of having this be... sorry, I should be talking while I'm thinking. Instead of having this be just a float and doing Euler to, doing a combine to Euler to rotation, we're gonna get rid of the combine. Now, obviously, they're all spinning whatever, but I want to change the initial rotation to be less uniform, so that they're rotating various amounts on all of the different axes. And we're gonna switch this to scale so that... Do we want to scale? Yeah, we'll go with scale. We were adding, now we're gonna multiply. It's fine. And now it's going crazy. Okay, let's maybe reduce that. And now we have some wild spinning monkeys simulating life as we know it. It's just silly things like that, right? Like, this is the fun part of computer graphics, just kind of messing around with things. It's so much fun. Anyway, thank you for that prompt, for asking, hey, can we instance other things? And then my mind just kind of ran with it, as you can see. Uh, but yeah, that's Game of Life, and then some. Another time, I'll definitely have to do this again, and I'll explain how we instance things in specific patterns, like I showed off. And yeah, do ununiform grids, but I think that's going to be all for today. That was a lot of fun, guys. Thank you so much for hanging out. I am very hungry. It is lunchtime for me. So that's all for today. I'm glad we took a look at Blender 4.4. Blender team doing amazing work as always. And I got to finally share one of the biggest projects that I've been working on for the last few months. It did not take me months to do this. It is taking me months to make the video. And finally, the information is out there despite my inability to finish that video. More than just trying to finish that video has been going on in my life. It's a whole thing, but I've been having fun. I've been using Blender for 4 years, but I'm definitely a newbie when it comes to geometry nodes. It's incredible how limitless geometry nodes is. I know I'll learn a lot from you. Thanks again. Absolutely. I'm so glad. I've only been using Blender for, I'd say 3 to 4 years now, but I focus specifically on geometry nodes. If you ask me to do things in other things, like I can do some hand modeling, but geometry nodes is my forte. I just focused on geometry nodes, and I love to teach geometry nodes. So like, I'm glad you're here. I'm glad you're willing to learn, because geometry nodes are great. It's limitless, like you said. And it's just incredible. That's why I want to talk about geometry nodes, because you can do anything. If you can think it, you can do it. You just have to learn how to do it. So, thank you for being here. Thank you everyone for being here. Everybody who's popped in and out, everybody who's stayed here. Y'all are wonderful, and before I continue to ramble, that'll be all for this one, and I will see you in the next one. Thank you so much. Bye. Oh, hey, bouncing back in here real quick to mention, I'm gonna upload this probably within the next hour or so to my Patreon for my paid members, because they are wonderful people. You all are wonderful people. Just wanted to mention that. There's also a ton of free content there I feel like I should plug. Thanks for being here for the shameless self-promotion. Lots of free content over there on Patreon. I will put a link in the description as soon as this is done. Thank you all for watching. Okay, bye.